We can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. We now know how our world ends. Our affinity with sci-fi movies and perhaps the Bible would point toward the big bad apocalypse. But what if we told you that the end of the universe is no different from its inception? The James Webb Telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago. In doing so, he gave us the most realistic starting point to imagine the end of the world. We can look to light that began its journey before there were galaxies, and that's the oldest light in the universe, which is, by the way, one of the pieces of evidence for people who don't believe in the Big Bang. The answer is, well, you can see it. We're heading towards Big Bang 2.0. Join us as we explore why the world has stopped expanding and James Webb's terrifying discovery. The Big Bang Theory, if we're certain about anything in our knowledge of the universe and its history, is the fact that our very epic of existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe, but we're not getting into the validity of these theories today. Mainly because the astronomical community has now readily accepted that our history in this universe starts with a Big Bang, and the ideas that succeed the Big Bang are also based on the same common point of the universe's birth. While the Big Bang is a common term in theoretical knowledge of astronomy and space, we're hardly aware of the nuances and the how of the phenomenon unless you're a nerd who has spent hours watching some excellent visualization of the Big Bang. To be fair, the phenomenon was more than an explosion, so to speak. Simply put, the Big Bang finds its origin in a single point, a point that was infinitely hot and dense that inflated to extreme lengths. All of this was when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of 34 seconds old. That is, 1/100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or inflation. During this process, space expanded faster than the speed of light, so yeah, you wouldn't have even blinked when the universe grew 90 times in size almost instantaneously from subatomic size to golf ball size. 1 second after the inflation, the universe began to cool, and that led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second, our universe was full of every particle we've learned about in our chemistry class, willingly or otherwise. Protons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively it looks like it, but our understanding of the universe's inception is highly theoretical. We've come a long way since the first moon landing, and since then, our technological advancement has grown exponentially. Back when scientists were studying the Big Bang only based on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. There have been some big breakthroughs in our pursuit to study the universe and explore space, yet even then, our existing technology is pretty limited. You see, we can't recreate the Big Bang or peer back at the event itself. Our biggest piece of evidence comes from the cosmic microwave background, which has allowed scientists to observe the echo of the Big Bang. While this mechanism is groundbreaking in the study of the universe, it's also theoretically limited. The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from the expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disproved as well. Yep, we're pretty sure about the Big Bang as the concept and how it was monumental in creating our universe, but there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that at this point in time, it's not easy to disprove the theory altogether. The theory is our universe still expanding. In the last decade or so, our only saving grace to study the Big Bang was the Hubble Space Telescope. And now, of course, all bets are on the excellent precision of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest points of contention in astronomical study was the expansion of the universe. If you pick up some science textbooks from the early 90s or so, you'd read about how the universe is widening. In other words, the universe is expanding, and that's one little scientific fact that we've held on to. But the real snafu here is that perhaps we don't understand what the expansion of the universe entails, and more importantly, we've got to ask ourselves if the universe is actually expanding. Because, spoiler alert, the James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped expanding. And hey, while the world is still intact, you might want to improve your internet experience to be safe and secure. Because we certainly have this. This is why we're happy to reveal our very own secret to secure browsing and accessing deep blocked content to make some hefty informative videos. Today's video is sponsored by the champion of safe and accessible internet, Atlas VPN. With more than 6 million users worldwide, Atlas is changing the game for everyone. Alright, this service won't be available in space, but Atlas would make your internet experience super secure and quick. Can't watch shows that are locked in your region? Connect Atlas and voila, you're in. You don't have to be an expert in tech or computers to use the service. It works like a charm for anyone and everyone. That too for just $1.83 per month, plus 3 months extra. So why choose Atlas? Atlas kills malware attacks, keeps your good searches secure, unlocks content from all over the world, and offers the best deals in the market. You can get all of this for all of your devices via a single subscription. Grab the big deal because now Atlas VPN Premium is just $1.83 per month, plus 3 months extra, and with a 30-day money-back guarantee. Protect your privacy and get many benefits of Atlas VPN for a ridiculously low price. You can take this deal by clicking the link in the video description below. Be quick, as it's a limited time offer. So while we thank Atlas VPN for sponsoring this video, click the link in the description to avail of the limited time offer. Your internet experience just got a whole lot better. And now, before jumping into the implications of this groundbreaking shift from our universe's theory, let's just talk about our understanding of this perplexing phenomenon in the first place. The most common knowledge associated with the Big Bang characterizes it as an explosion. Well, fiction and popular media have put solid imagery to this process as well. Any piece of media would depict the inception of the universe as some sort of blast that hurled tons of energy and matter, just spreading in every direction. Scientifically speaking, that sort of visualization isn't correct. Despite the widespread use of the explosion analogy, the birth of the universe wasn't exactly a blast. Scientists want us to correct our understanding of the universe. In NASA's own words, the universe did not expand into space as space did not exist before the universe. Instead, it is better to think of the Big Bang as the simultaneous appearance of space everywhere in the universe. Our understanding of the phenomenon also reveals that our universe has lived through a durable cosmic period that was only disrupted by the reionization in space. Before that particular chemical conjecture, our universe was just pitch black. The let there be light moment of the universe only occurred 400 million years after the Big Bang. Yep, that's right. You see, the big explosion only created the basic tenet of all living beings and heavenly bodies in the universe. For 400 million years, the universe was plunged into darkness because, well, it's simple, there were no stars or galaxies. When that was rectified, as clumps of gas turned into stars and galaxies, only then did the universe get out of its cosmic dark ages. So here's a little trivia for you guys. When do you think our solar system came into being? If the universe was just darkness and eeriness for 400 million years, well, our solar system was born 9 billion years after the Big Bang. So yeah, sorry sci-fi movies, there's a huge disconnect between the so-called explosion and scientific theory. And of course, this changes everything. The way things are, our universe still exists as a single inception point. It hasn't moved or expanded ever since the Big Bang. What really happens is that space has been stretching along with time, and it carries matter with its trajectory. To put it in clear-cut words, the universe isn't expanding the way we visualize it or even understand it. It is actually the active stretching of space that precedes the expansion of the universe. We know it's a bit complicated to comprehend this, but it's also important to understand the implications of what we're about to tell you. For the purpose of this video, we continue to use the phrase expansion of the universe to signify the active movement of our space, mainly because even scientists are comfortable using the exact framing to describe the recent discovery made by the James Webb Space Telescope. The fact that the universe has stopped expanding is both terrifying and inconsistent with our previous theoretical knowledge of this baffling phenomenon, because you see, before the shocking discovery, scientists were convinced that the universe was expanding at an accelerated rate since its inception. And well, they weren't wrong. With the help of the Hubble Space Telescope, scientists were able to gather concrete evidence to support their theory. So no, this isn't the case of NASA correcting its earlier understanding of the universe's expansion. Whatever is happening to our universe, it's entirely new and possibly irreversible. While the discovery itself is profoundly frightening, it isn't overly unexpected either. As we talk more about gravity, you'd see that our universe was always susceptible to a recollapse. In the case when the universe had an ample amount of energy density, its expansion would stop entirely. By the looks of it, our universe is going backward. Origin of dark energy. Back in the 1990s, NASA and its credible scientists had some very conclusive ideas about the expansion of the universe. The most fundamental unit of their scientific understanding was gravity. While that much still remains true today, we have some entirely different ideas about the speeds at which our universe expands. As we've already discussed earlier, scientists had a theoretical prediction about the universe's recollapse that would cease the expansion as we know it today. But also, the contesting idea was equally terrifying, if not jarring. Too little energy density would mean that our universe would never stop expanding. The uncharted business of the idea is quite limited today, but you see, it was the 1990s and scientists had little technological help to find tangible or observational data for their predictions. What they were certain about was that as our universe ages, gravity would definitely decrease the rate of expansion over the course of time. Of course, and even intuitively, it makes sense, gravitational pull brings galaxies together. This is something we've already established. So as the universe would expand, the gravitational force would resist widening the distance between the heavenly objects. Since our universe is just a patch of matter, the attractive gravitational pull would keep the matter intact. This theory was also extended to understand the rate of the universe's expansion. Scientists believed that since gravity is the binding glue for all of the matter and has existed since the universe's inception, the rate of expansion had to slow down. Sure, we didn't have any means to observe this phenomenon or carry out some big data testing, but theoretically, this made complete sense until it didn't. In 1998, the invention of the Hubble Space Telescope, HST, changed everything we knew about the universe. HST was effectively used to study the distant supernovae in our universe, which explained the fluidity of our space. This is to say, scientists employed supernovae to study the expansion of the universe. What they found out was completely opposite to what they knew about our universe. And let's just say scientists were left completely dumbfounded and clueless. After all, the whiplash was monumental. Not to mention, this single discovery meant that astronomical studies had to be inherently rewritten and revised. Scientists had to look back at their theoretical studies and change everything on the basis of what the Hubble Space Telescope showed them. And there was no room for error in judgment. For the first time in the study of the universe, seeing was believing. It turned out that gravity wasn't slowing the expansion of the universe at all. In fact, the universe was expanding at a higher acceleration than it had ever before. You heard that right. Ever since the universe's inception, the rate of expansion had only increased from its earlier data points.